about the household energy transition in India and its climate, air quality, and developmental implications, as Milind mentioned. In terms of my general thesis, I look at the intersection of air quality improvement and climate change mitigation actions, specifically in India. And I look at it at 3 different scales. One is the household level, focus of today's presentation. Secondly, at a regional scale, which involves spatial analysis of particulate matter exposure in India. And lastly, the effort is to integrate the household level and the regional scale models into a national level economy-wide framework. So why is air quality a matter of concern in India? If we look at this map of the number of deaths from air pollution in 2013, we see that India is one of the 2 countries with the largest number of deaths. And in fact, the majority of these, approximately more than 900,000 a year, they can be attributed to indoor air pollution, which is a result of burning solid biomass for cooking or heating, and kerosene used for lighting. In terms of greenhouse gas emissions, there's a dichotomy between total greenhouse gas emissions at a national level and per capita emissions. So if you look at the total emissions, India is one of the top 10, the 4th largest emitter of greenhouse gases, which implies that any action that the government takes to address climate change will make an impact in terms of global climate change mitigation. But on the other hand, the per capita emissions in the country are lower than world average. And so as much needed development happens, people are expected to use more energy, and per capita emissions are expected to rise. If we look at the distribution of greenhouse gases for a given year by source, the chart on the right shows the Kyoto emissions, or the emissions that are included within the Kyoto Protocol. So carbon dioxide, methane, nitrous oxide. And if we look at the distribution by source, then residential emissions only form about 7% of these. But the chart on the left shows, the chart on the left over here shows the non-Kyoto emissions, or the pollutants that are not covered under the Kyoto Protocol, say black carbon as an example, but pollutants that have significant global warming potential. And if we look at that chart, then residential emissions form the majority of these. If we're comparing numbers, then the non-Kyoto residential emissions from lighting or kerosene and cooking from solid biomass are actually equivalent to the industry emissions that correspond to Kyoto gases. Okay, so what do we mean by the household energy transition as it's happening? People move from using traditional biomass like fuel wood and dung to gas for cooking, or specifically liquefied petroleum gas. And people move from using kerosene lamps for lighting to electricity. In spite of the general transition over the last few decades, approximately 819 million people in India still use traditional biomass cook stoves, and more than 250 million people in rural India do not have access to electricity. Now, on an individual basis, modern energy access is significant, not just from a health perspective, where burning biomass and using kerosene for lighting emits particulate matter, and particularly PM2.5, or particulate matter that's less than 2.5 microns in diameter, are specifically harmful for health. But apart from the health perspective, modern energy services provide a number of other benefits. Like they reduce the time that women spend collecting firewood. Electrification increases the time that's available in the evening to study. It allows home businesses to stay open longer, and a whole host of other benefits. So if we look at the past work on clean fuel adoption, firstly, a number of cross-sectional studies they show that LPG or gas and electricity, they provide a number of developmental and health benefits. But because of the nature of these cross-sectional studies, they cannot quantify the benefits that are actually experienced by a household that makes the energy transition. Clean fuel adoption in households is primarily driven by income and by urban-rural location, where urban households adopt clean fuel at a much faster rate. But even when households adopt gas and electricity, they often use it along with other solid fuels, or they stack them. And so we need to analyze the climate and air quality impacts of the different rates of transition across income groups and across urban-rural locations. And lastly, more recently, modeling studies predict a rise in CO2 emissions as households move from traditional biomass to modern energy services. But these studies don't consider non-Kyoto pollutants like black carbon. Which brings me to my research questions for this study. So the first question I address are, what are the specific developmental benefits that are experienced by households that have made the energy transition in India? Question 2 is, what are the climate and air quality impacts of different rates of household energy transition across income and rural-urban groups? And the last question is, should extending fossil fuel-based modern energy services to households, should it be a worry vis-a-vis climate change? The data for question 1 comes from a nationally representative survey called the India Human Development Survey, in which more than 40,000 households were interviewed in 2005, and then they were re-interviewed in 2011. The focus of this survey is development and family health. So a number of variables from this survey are important, like whether households have access to gas and electricity. If they do have access to electricity, how reliable is that access? How much time does each household member spend on cooking and on collecting fuels and various different activities? The data for questions 2 and 3 come from another nationally representative survey called the National Sample Survey, where more than 100,000 households are interviewed every 5 years. The same set of households are not interviewed every 5 years, unlike the IHDS. And I'll be using data from years 1987 and 2009. This survey has a consumption focus, so the important variables from this are the different types of fuel that are used, the quantities that are used every month, the amount that people spend on each type of fuel every month. Okay, so from the NSS data set, if we look at this graph, the top row is rural households, bottom row is urban. Left column is 1987, the column on the right is 2009. And on the x-axis, we have income groups, where 11 is the lowest income and 0 is the highest income. And on the y-axis, we have percentage of households. Then we see that in urban India, there's an almost complete transition from 87 to 2009, from kerosene, which is the gray area, the gray bars, to the blue bars, which is electricity. In rural households, about a third of the households still rely on kerosene for lighting, or still relied on kerosene for lighting in 2009. Only rural households that are in the top income decile over here, so the top 10%, have adopted electricity as the only form of lighting. A similar graph for cooking fuel shows that LPG adoption which is the green bars over here, is significantly higher in urban households than in rural households. LPG adoption rises with income, and the effect is, you can see the effect in both rural and urban households, although it's more pronounced in urban households. In terms of dependence on firewood, which is the orange bars over here, the bottom urban 10%, and most of rural India in 2009 depended on firewood for cooking. Okay, so I'll address question 1 first, which is the developmental benefits of household energy transition using the panel data for 2005 and 2011 from IHTS. The method used here is fixed effects regression, where I'm estimating the impact of energy transition within each household at 2 points in time, 2005 and 2011. I'll talk about 3 of the indicators or dependent variables that I've looked at. One is time saved in cooking, time saved in collecting firewood, and respiratory illness in household members. Each of these dependent variables have their own set of explanatory variables. The key one in all of them, though, is a transition in the fuel type that's used. Okay, firstly, the time saved in collecting firewood. Collecting firewood is more of an issue in rural households. In urban India, households that use firewood mostly buy it. In rural households, if we look at the percentage of households in 2005 and 2011 that collect firewood, percentage is almost the same across years, approximately 35%. And in these households that actually travel to collect firewood, women spend almost twice as much time as men collecting fuel. The average time spent in both years is approximately an hour a day. And the results from the regression equations show that when these households partially adopt LPG, they save about 21 minutes a day in fuel collection time. Okay, time saved cooking. The average daily stove use time is 3 hours, and this accounts for cooking meals, heating water, making tea, all of that. We see that simply adopting LPG or using gas while using other solid fuels, it leads to negligible savings in time, about 3 minutes a day for rural households. But on the other hand, when households move from using solid fuels to only gas, it saves them about 14 to 18 minutes a day. A few other factors that turned out to be significant in terms of saving time cooking was ownership of refrigerator in rural households. So if households bought a refrigerator between 2005 and 2011, then in 2011 they spent 18 to 22 minutes a day less time cooking. And the other factors were the number of meals cooked in a day, number of household members in a family. Of course, they all increase the time required to cook. The last indicator is respiratory illness. The method used over here is fixed effects logistic regression with the dependent variable as the incidence of respiratory illness in non-smoking male and female household members. And again, the results are somewhat similar to cooking time, where partial adoption of LPG, it doesn't show any statistical significance in terms of reduction of odds of respiratory illness. But complete adoption of LPG, so when households move from using solid fuels to LPG only, it reduces the odds of respiratory illness by about 50% in female members and 20% in male members in rural households. Similarly, switching, when households move from using kerosene lamps to electricity, that too reduces the odds of respiratory illness by 22% in female members and 15% in male members. So to summarize, the energy transition has health and developmental benefits which are greater for women than men. LPG does save time in terms of cooking, so when households move from using firewood that is collected to gas, they can save an average of 80 minutes a day. Gas and electricity reduce the odds of respiratory illness in both men and women, but partial adoption of gas doesn't seem to have any respiratory health benefits. So questions 2 and 3 are climate and indoor air quality. The data for this comes from the National Sample Survey. In terms of climate, I've looked at Kyoto and non-Kyoto gases, and for air quality, I'm looking at particulate matter intake, specifically PM2.5 intake. If I calculate the greenhouse gas emissions that include Kyoto and non-Kyoto gases, then again, the top row here represents rural households, bottom row is urban households. column on the left is 1987. This is 2009. 11 is the lowest income group. 0 is the highest income group. Then we see that total rural emissions actually exceed urban emissions if the non-Kyoto pollutants are considered, which basically means that there are opportunities for reducing emissions in rural areas. In urban India, we see that there are rising emissions with income, and these rising emissions mostly result from rising electricity consumption. But in rural India, there's very little variation when it comes to greenhouse gases and income, and this is mostly because these emissions are from cooking fuel, and cooking fuel usage varies very little with income. Per capita PM 2.5 intake, rural exposure is actually very high irrespective of income in both years. If we compare the PM 2.5 exposure to smoking a cigarette a day, then we see that in most rural households, the exposure exceeds smoking 5 cigarettes a day. In urban India, exposure reduces with income because there's a transition to LPG happening in urban India. The last section of this analysis, and I don't have time to go into details, is a scenario analysis of future energy transition, where I projected urban and rural fuel consumption patterns from 2009 to 2020, which is the year for which the government has targets for electrification and LPG adoption. And I looked at a number of different scenarios. So there's business as usual, there's a government-defined minimum access to LPG and electricity, and there's an ideal scenario with a complete transition to LPG. And the point of looking at these different scenarios is to compare the different cases of greenhouse gas emissions and particulate matter exposure. And the takeaway from this exercise was a transition from firewood to LPG in rural India. There's a climate case for that transition as well, because in the case of moving the firewood consumption in rural India to LPG, non-Kyoto pollutants would be removed. And in urban India, emissions are largely driven in the future by rising electricity consumption in the middle and high income households. So to summarize, quantify the developmental benefits of energy transition, and we see that there are strong time saving and health effects of moving from firewood to LPG. And these benefits are related to gender, so women experience more of these benefits than men. And then from the NSS dataset and the scenario analysis, we see that an energy transition to gas and electricity, to gas in rural areas, it results in negative to low net positive increase in carbon dioxide emissions compared to a business as usual scenario if we look at multiple different future scenarios. And more specifically, the future climate challenge is related to the electricity consumption in the middle and high urban households. So, thank you. I wanted to thank Milan and Hadi and Bridge for funding part of this work, and the IRS community. Questions? Right. So rural is, like, we're going with the definition of the government. So the government defines rural as areas with population density less than 400 people per square kilometer. But what ends up happening is, you're right, there's a lot of regional variation in terms of rural energy use and urban energy use. not for this analysis, I haven't taken into account the regional variation, but there's a part of this analysis that has taken the different states and the different districts into account. Mm-hmm. Right. Right. So the emission factors or the emissions per unit fuel for each of these gases are taken from literature, and so is the global warming potential. So, for example, each Kyoto and non-Kyoto pollutant will have a global warming potential that brings it to the same scale as CO2, and these numbers are taken from literature. Right. So each of these fuels will have its own sort of emission factor, right, of each different gas. And so the way I've done it is calculated the emissions of each different gas from each of these fuels according to the emissions factors from literature, and then converted the total emissions of each of these gases to a CO2 equivalent using a global warming potential factor, again from literature. Mm-hmm. Right. So in the analysis of the developmental benefits, it doesn't sort of calculate an average benefit across deciles. It calculates the benefit for each household. So in this case, in the way I've done it, the household would still be within that same decile, right? So the benefits that are experienced by each household speak to that household, and over the years it may have moved up one decile, but it's still sort of within the same range of income. Does that make sense? Yeah. It's the average effect. For each decile. Yeah, you're right. So the smoking question is on an individual basis, and so just the person doesn't smoke. Yeah, so there is no data on secondhand smoke directly, but I mean that can be calculated because I know in each household I know who smokes. Yeah. On the time that's used for cooking. In general, the question is, how much time do you spend in a day using the stove? And in general, they ask them to think back for the last 30 days. So, yeah. Yeah. So I deal with, in general, the second part of my thesis looks at ambient air quality. And in general, if I map out the use of firewood in the country geographically. And I also map out ambient air quality in the country geographically. There's a very strong correlation between ambient air quality and firewood usage. So I mean, I can't really speak to the causation of it, but in general, household usage of biomass is expected to have an outdoor effect as well.
So moving to electricity might have an impact on climate change, but it might actually
Ambient air quality as well.